Now that we've taken a look at how to add and subtract radicals, the next question is how do we multiply radicals? And the way we multiply radicals is we'll have some number outside of a radical and a number inside a radical, multiplied by some number outside a radical and some number inside a radical. And the basic rule is things outside of the radical can be multiplied together, so a and c, and things inside the radical can be multiplied together, b and d. And so we're going to simplify those separately and see what we end up with. My only tip is to simplify. It's helpful if we factor the radical, because sometimes something will come out of the radical. Let's look at a couple examples. Let's start with doing 4 times the square root of 6 times 2 square roots of 15. First thing I'm going to do is I'm going to factor those radicals. So 6 is 2 times 3, and 15 is 3 times 5. One thing I notice is as I multiply these together, I actually have a pair of 3's under the radical. That's 3 squared. So I'm going to pull out a 3 outside of that radical. So I'm left with 3 times 4 times 2 outside of the radical. And inside the radical, I have a 2 times 5. In other words, I have 24, multiplying the outside numbers, times the square root of 10. Let's take a look at another example where we multiply. Let's take 5 root 10, and let's multiply it by the binomial 2 root 6 minus 3 root 15. Now, we already are familiar with the distributive property that says I'm going to distribute that onto both parts. So as I do that, I've got 5 times 2 outside the radical and 6 times 10 inside the radical. Minus 5 times 3 is 15. Inside the radical, I have 10 times 15. Well, before I multiply inside the radical and get big numbers, I'm going to factor what I have in here. 6 is 2 times 3. 10 is 2 times 5. Notice I have a pair of 2's in here. I'm going to pull out a 2 then. That's 2 squared, comes out as a 2, leaving behind 2 times 10, which is 20, times the square root of 3 times 5, which is 15. Minus, let's see how this next one simplifies. 10 is 2 times 5. 15 is 3 times 5. Notice the pair of 5's, that's 5 squared. Pull out the 5 squared, and I have 5 times 15 now, which is 75, times the square root of 2 times 3 left over, which is 6. And we've now simplified that expression. Let's scroll down a bit and try a few more examples. Let's try 3 square roots of 7 minus 2 square roots of 5 times the square root of 7 plus 6 square root of 5. Well, we've done problems like this before. We just need to multiply this out, distributing the 3 root 7. Notice when we do that, we get root 7 times root 7. Square root of 7 times 7 is 7 squared. With 2 7's under the radical, we can pull 1 out, and there's no more radical left. What if we do 3 times 6? That's 18. Square root of 7 times 5. 2 root 5 times root 7 is negative 2 times the square root of 5 times 7. And negative 2 times 6 is negative 12 times the square root of 5 times 5, which means we can pull a 5 out. Doing a little simplifying, 3 times 7 is 21, plus 18 root 35, because that's not going to factor anymore, minus 2 root 35, minus 12 times 5 is 60. 21 minus 60 is negative 39, and 18 root 35 minus 2 root 35 is a positive 16 root 35. We have our solution. Let's do one last example. Let's try 2 plus 3 root 7, and we're going to square it. Now, squaring means multiply by itself. It means we're going to take 2 plus 3 root 7 and multiply it by another 2 plus 3 root 7. And then it becomes very much like the previous problem. We can FOIL it out. 2 times 2 is 4. 2 times 3 is 6 with a root 7. 3 times 2 is 6 with a root 7. And 3 times 3 is 9. And root 7 times root 7 is just 7, because that 7 squared comes out. No more radical remaining. Doing a little simplifying. These radicals don't simplify at all, but 9 times 7 does. That's 63. So if we combine like terms, we end up with 67 plus 6 is 12 square roots of 7. That's how we can multiply with radicals, multiplying outside numbers, multiplying inside numbers. But as we do, check to see if we can simplify those inside numbers as we multiply. In our last video for this section, we're going to look at how we work with other roots beyond just square roots.